So here are two different limits. And first thing you do when you see one of these limits is you just plug in that value for x. And right away, we wind up with this 0 over 0 if we plug a 0 in for, a negative 4 in for x. That's 16 minus 48 plus 32, and this is negative 4 plus 4. So 0 over 0. So we're going to see if we can do something about that, or if this is just, we can't do anything about it. So any ideas? What should we do to see if we can avoid the 0 over 0 thing and make the limit exist even if the function doesn't exist? I believe that is the factor the expression. And yeah, so we can factor this. So two numbers that add up to 12 and have a product of 32. Uh-oh, I forget already. Oh yeah, x plus 4 and x plus 8 are going to do the job. And that's all over x plus 4, which is our criminally implicated 0 over 0 part of the whole expression. Those are going to cancel. The function still won't exist when x is equal to negative 4. But if we looked at this on Desmos or something like that, and we looked at either side of that little discontinuity, which is a removable discontinuity or a hole, we would see that it approaches 4 both from the left and from the right. And so even though the function doesn't exist, the limit is going to exist right at x equals negative 4. Okay, very good. I think we actually have room on the board to manage this. So the question actually, and I don't have the limit written in here, but I should, because this is the limit as x approaches a. And so this is one of these crazy ones, 17b, where x isn't even approaching a number, it's approaching a letter. Well, I'm not sure, like a plus 4a is 5a squared here. And 5a squared is 25a squared minus 25a squared. I'd get a 0 on top. And a minus a, I'd get a 0 on bottom. And so we have to fix this. We have to look for the criminally implicated element in this top part. Okay. If you looked at that and you said you have to factor it, which I think is easy. Yeah, definitely. You expanding it would probably just be horrible and ugly. So we're going to factor it. Can you tell what kind of factoring this is? This is a tricky one. If you thought of this as being like the x, and this is being like, if this was x squared minus 25, what would you do? Difference of squares. Okay. And this is something squared subtract something squared, so we can still do difference of squares. And so this is going to be x plus 4a minus 5a times x plus 4a plus 5a. And this is all going to be x over x minus a. Okay. Things still aren't looking that much better, but I do see that inside these brackets, I can start to simplify things a little bit. So our limit is still headed for a, not for 0, the way I just wrote there. And so this simplifies to x minus a, x plus 4a minus 5a. And this simplifies to x plus 9a. And this is all over x minus a. And I can see I can cancel out my criminally implicated elements. And it looks to me like I can dump my limit in now. And this is a plus 9a. And so this whole expression is going to approach 10a, whatever a is. Once again, the function itself is not going to exist when x is equal to a. It's a 0 over 0. But if I looked at it from the left and the right, it's going to approach the identical value. And so we say the limit exists. Okay, Let's take a look at 17. Oh yeah, 17C, yes. Sorry, I was looking at 18 thinking, oh, that's just ugly. I don't want to do that one. Not to say I always judge problems based on their appearance, but I did judge that one based on its appearance, so I guess I can't sound too self-righteous about it. Okay. And so this one, limit as x approaches 0. So this one involves radicals. I love radicals. They make us re-examine the things that we're doing. Just made an extra piece of chalk. Okay. How are we going to fix this? Oh my goodness, look at that. If I put a 0 in for x, the top becomes 0 plus 5. Square root of that is the square root of 5. And, 0 minus 5. Is this really x approaches 0? No. This is 5 minus x. I jumped to conclusions there. There. That makes sense. Wouldn't exist in any situation. So it's going to be the square root of 5 minus the square root of 5 on top, which is 0, divided by 0, which is 0. And so this function apparently does not exist when x is equal to 0. Any ideas how to fix this? Multiply by the conjugate. I'm recognizing that. Let the record indicate. We had the multiply by the conjugate symbol. Yes, very good. And we can't just willy-nilly multiply the top by the conjugate. We have to make sure we don't actually change the expression, or at least produce an equivalent expression. Okay, good. This is going to manage this thing on the top. Limit as x approaches 0 of this, and it becomes x plus 5 minus, and this is 5 minus x, and this is all going to be over x. Oh, look at this. What a thing of beauty is happening here. This is the limit as x goes to 0, and x minus negative x is 2x over x, and that's still 0, but when I cancel out these x's, I get a 2. And so this is the limit as x goes to 0 of, oh, no, that's after I dump in my limit. Sorry, so I shouldn't write my limit sign again. That would just be wrong. So the value of that limit is 2. Okay, so quite often when you see these radicals, you're dealing with multiplying by a conjugate somehow or other to fix things. Okay? All right, let's do 17D. 17D, oh my. 17D has a cube in it. Those are our favorite. Limit as x approaches 2 of x squared minus 4. Oh, I know how to factor that one. And x cubed minus 8. So there's a nice formula for factoring differences of cubes and sum of cubes. And of course, because it's a formula and it involves committing things to memory, I absolutely refuse to do it. But this one on top, this is easy. That's easy. X plus 2, x minus 2. Okay. And we're going to factor out this x cubed minus 8. Let me make sure. Yes, it's x cubed minus 8. Okay. I'm pretty sure that it's going to be an x minus 2 on the bottom. Okay. In fact, I'm pretty sure that it has to be that. Did I memorize that, or is there a way to say, yeah, definitely we have that? Okay. Anyways, something is being multiplied by x minus 2 to leave us with x cubed minus 8. And we have to figure out what that something is. So something times x is x cubed, and so that's x squared. So I know in this box, this must be a minus 2x squared. Now in my original expression, which is x cubed minus 8, there aren't any x squareds. And so I know that this must have been a 2x squared in this box. X times something is 2x squared, and so this must be a 2x, which means that this is minus 4x right there. And because there is no x term in this, this has to be a plus 4x. And that's going to work out something times x is plus 4x, and so this is a plus 4. And I see that that works out. 4 times negative 2 is negative 8. And so the second part of this is x squared plus 2x plus 4. Okay, that roughly fits with what my understanding of how the difference of cubes factors out. The x minus 2's cancel. Those are the ones that are criminally implicated in making this limit seem non-existent. And now we've got x plus 2, which I didn't have to put in brackets, but nonetheless did. And now I can dump in my limit, and it just becomes 2 plus 2 over 4 plus 4 plus 4, which is child's play. There we go. Okay, same game. Factor everything, just go crazy. 1/3 is the answer. Okay, once again, point discontinuity. Next one, 17E. Oh, look, it has radicals in it. More radicals than a revolution. 17E, 4 minus square root of 12 plus x over x minus 4. And I can guess that this is the limit as x goes to 4. And yes, my failing vision tells me that's what it is. And let's see here now. Sure enough, 12 plus 4 would be 16. Square root of 16 would be 4. 4 minus 4 would be 0. 4 minus 4 would be 0. I'd have 0 over 0, and it is stubbornly refusing to tell me what the actual limit is because of that. Okay. Hey, what should we do to fix this? I believe that that was multiply by the conjugate. All right, good. I think that's what we'll do. We're hoping for the best here. 4 plus the square root of 12 plus x. And we can't just willy-nilly multiply the top by that. This is just exactly like multiplying the whole thing by 1, which always makes the same thing. Good. Here we are. We'll say a little prayer to hope that this makes all the bad stuff give away. So go away. So this is going to be 4 times 4, which is going to be 16, and then minus, and then just 12 plus x. There we go. And we have really a horrid mess underneath. But that's okay. We're just going to take a deep breath and hope that this is going to work out. Okay, so still haven't been able to do anything with the limit, so we're going to have to leave it on the outside. So this becomes negative 4 plus, minus x. Oh, no. 16 minus 12 is positive 4 minus x. Okay, got too excited and ahead of myself there. X minus 4 and 4 plus the square root of 12 plus x. Oh my goodness, if only x minus 4 divided into 4 minus x in some nice even way. And the answer is that it does. It's being disguised. This divided by this is just negative 1, and this is 4 plus square root of 12 plus x. And look at that. I can do this. I can substitute this limit in, and the whole expression does not vacuum into a black hole somewhere. So this is negative 1 over 4 plus 4, 8. Hope that's the right answer. There we go. Once again, just relaxing, multiplying by the conjugate. Everything turns out all right. The next one. Ooh, this one doesn't have conjugates in it. Looks nasty. For sure. So this is 17F. It's got fractions. Who invented fractions? Quick question. Nobody knows. So 1 over x times bracket 1 over 2 plus x minus 1/2. Okay. Limit as x goes to 0. Oh, look, it spoils it right there, right off the bat. The 1 over x thing just explodes on us. So that's undefined. This is okay. That just turns into a 0. But since they're asking us, we probably have to do something with this. And I think what's going to happen in the end is the x's are going to cancel top and bottom. But let's investigate further. So these are fractions. What do we need to do to subtract fractions? Is that the common denominator? Yes, let the record indicate. We'll bring this thing to a common denominator. And it's my favorite common denominator where I don't have to worry about the lowest common denominator. I'm just going to multiply those two things together. Okay. And this must be a 2 here, and this must be a... This must have become 2 plus x. Sorry, I did that all in one step, one big go. I'm going to write common denominator, which is uncommon for me to do. So we did the common denominator thing there. If you want to do the intermediate step, I think that's good. Okay, so let's do this now. Limit as x goes to 0 of 1 over x. And so this is a thing of beauty. 2 minus 2 is 0. And so this is x on the top of this expression. And this is 4 plus 2x on the bottom. And look, the prophecy has come to pass. The x's are canceling, top and bottom there. And this whole thing winds up just being, I can dump my limit in now. It's safe. The expression doesn't go to 0. It just becomes 1/4. Okay. Good. Everything worked out according to plan. So this goes over all those tricky little things. Factoring, various tricky forms of factoring. So difference of squares, for example, that involved terms that had brackets. Sometimes you can even get difference of cubes where it's something like x minus a cubed minus y minus 3 cubed, or even to the 6th. I don't think we're going to see something like that, but you might have to factor that as a difference of cubes. Okay, last thing I'd like to do is I would like to look at this one with the absolute value function in it in question 18E. Because absolute value is a favorite of universities. And this has the effect of making our function, the limit of this function as x approaches 0, it makes it so it doesn't exist. And so the actual question is, explain why that. So explain why the limit as x approaches 0 of the absolute value of x over x does not exist. Okay. And so for sure, the function doesn't exist as x approaches 0 because we've got that 0 on the bottom, and ultimately it would become this 0 over 0 thing. But we know that the function might not exist right there, but that the limit might exist. In other words, if it looks kind of like this, and all the functions that we just did would look at like this, where they have a removable discontinuity. For the limit not to exist, what has to happen is the limit from below has to be different from the limit from above. Okay, so there was this definition for where the limit from below has to equal the limit from above for the actual limit to exist, and we're asked to explain why that doesn't happen in this function. If you look at this on a graphing calculator, it's actually kind of neat. And so you get the regular Cartesian plane, and you'd see that this actually approaches 0 from below, and it's -1. And then it just goes ahead and picks right up at +1. And so the limit from below is not equal to the limit from above when you do the graph. And the absolute value function can be defined piecewise. So the absolute value of x is equal to -x if x is less than 0. And it's just equal to x if x is greater than 0. You can see what's going to happen here. When we approach it from below and above. Okay, so let's approach it from below. So using our piecewise definition here, this becomes -x over x. And I'm happy with that because I can just cancel these out, dump in my limit, and it's equal to -1. Okay, because I don't even I'm not even left with an x there. What about when we approach it from above? Well, x is just equal to x. That's divided by x, which is equal to 1. So the limit from below is not equal to the limit from above. Therefore, that limit does not exist. And so that's the game you're playing, basically, if you're finding out that a limit doesn't exist. The other thing that can happen, and you'll see that this happens with some of the other functions. So for example, the limit as x approaches 3. So this is, oops, that wasn't 17e for those of you who might have thought it was. It was 18e. If we looked at this one, which is 18a, which is the other example, so in this case, we don't have to look at it really too detailed, okay? But the domain of this function is any real number, just as long as that real number is greater than or equal to 3. I can't put in a 2 because 2 minus 3 is -1. I take the square root, bam, calculator blows up right in my hands. I have some sort of math wound after that, okay? So the limit as x approaches 3 from below does not exist. So the limit from below, there's no way for it to equal the limit from above. Which is 0. So once again, the left and right hand, or the limit from below and the limit from above, don't equal each other. So that limit does not exist. That's it. That's all the tricks.